Okay, y'all, so let's just go ahead and continue where I was trying to go. What happened is my computer actually ran out of battery juice. I thought I plugged it in, and apparently what happened is it ran out of battery power. So that kind of sucks. So it's going to have to recharge now. But anyway, so this is the growth factor with the base of 2. This is the exponential model. When the exponent of both of these is 0, this becomes to 1, because anything to the 0 power is 1. Now if we had a number multiplied to that, then this would become 3. Alright, now the only difference between these two is that this is 2.71, which is bigger than 2, so the graph of Euler's function would get bigger and drop quicker. Because as you go to the right, you're multiplying. As you go to the left, you're dividing, or you do the reciprocal. So multiply 2 as you go to the right, multiply 1/2 as you go to the left. Okay, now if the base is greater than 0 and less than 1, or the rate is less than 0, then we're going to have a decrease. So then what we'll have is this graph. Okay, so if we had 1/2 to the x, or e to the negative x, that would be the graph. All right, and this is essentially saying the same thing as 1 over e to the x. All right, so notice 1/2 is bigger than 1 over 2.7 something. So if we graph the 1/2, that's going to not drop as quick. Okay, so notice these are related to each other. They're basically reflections across the y-axis. I'm so bummed about the computer. I'm looking at it now. I hope I didn't break it. That would suck. Alright, and so those are the basic shapes of the graphs. If r is positive, this is going to represent percentage of increase. If b is greater than 1, same thing. If r is negative, it's going to represent a percentage of decrease, and in that case, the growth factor b base would be between 0 and 1. Okay, so now what we want to do is make graphs based upon transformations. So in other words, if we had these 3 graphs, well, the first one would just be right here, and that would be 1, again, because anything to the 0 power. Now if there was a 2 multiplied in front, then that would be a 2. Okay, so then making the other 2 graphs. This one changes the sign of the output, so the y's are changing sign, so that means this is going to go flip over the x-axis. And you could think, well, the only difference between these two is these are getting bigger positively, these are getting bigger negatively. Again, the base is always positive, so that means 3 to the x, and then we change the sign. Okay, and the way this works is we're multiplying by 3 as we go that way, whereas when we go this way, we're multiplying by 1/3. because we're going to be using negative x's, which means the negative reciprocal, or sorry, the reciprocal. All right, so then the only difference here is that they're negative. Okay, and then the other one, the last one, this is where you change the sign of the x. So this is where you reflect across the y-axis, which we kind of looked at that previously. Okay, now this would be no different if this was e to the x, e to the negative x, oh, sorry, negative e to the x or e to the negative x. No different. All right, now what if we had some different kind of transformations? All right, what if we had 3 minus 10 to the x? Okay, well, what's the parent? Well, the parent is 10 to the x. And then it looks like we're multiplying by a negative, so this would be a reflection across the x, and then we're changing the sign of the y. And here we're adding 3, so that's going to be a vertical translation up 3. So the parent okay? Now this has an asymptote, and I haven't brought that up until now, because as x becomes negative, this is basically becoming 1 over 10, and so 1 over 10 to the negative 3, 1 over 10 to the negative 1,000, this is gradually dropping to 0. So this has an asymptote of y equals 0. Because again, if you think of it as times 10 going to the right, times 1/10 going to the left, then this is going to gradually get smaller and closer to 0. All right, well, what about the next transformation? Well, that would be the reflection across the x. So that means this graph. Okay, and then notice the horizontal asymptote did not change. It only changes if you go up or down. So we're just flipping over axes. Okay, and then this means we're going to go up 3. So once we flip over the axis from 1, that becomes negative 1. And if we want to go up 3, we're going to go up 1, 2, 3. So this horizontal asymptote is going to now be at 2. Or rather, my bad, I'm sorry about that. No. Not the horizontal asymptote. The point is going up 3. So the negative 1 goes up to 2, whereas the horizontal asymptote at 0 goes up 3. So that's going to be right here at 3. Almost lost track of what it was doing. Okay? And this would be the same if this was 3 minus EX. All right. Well, let's look at one more. So let's say we had minus 2 minus e to the negative t. All right, well, the parent. And then looks like we're changing the sign of both of these. So we're going to have a reflection across the x, reflection across the y. And then we're going to go down 2. So vertical translation down 2. All right, so our parent, when, again, y equals 0 is the horizontal asymptote, because this is to the 0 power. Anything to the 0 power is 1. And if we multiply e, we go this way, and if we divide by e, we go that way. So again, remember, e is 2.71 something. So it's going to get bigger as you go to the right, and it's going to drop down to 0 as you go to the left. Okay, so then we got the reflection across the x and y, so it's going to reflect across both the x and y. So it's going to do like this, and then it's going to do like this. And this would be -1. Okay, now that's dropping down 2. So this -1 is going to go down 1, 2. So now it's going to be a -3. And the horizontal asymptote is dropping down 2. So it's going to go from 0 to -2. And so then the resulting graph would be like that. Okay, and so now if we're solving equations, and we have the same base, we can just put the exponents equal to each other. If we're solving equations and we don't have the same base, then we got to do a little bit more. Sometimes we can get the bases equal to each other. So for instance, 8 is the same as 2 to the third. All right, now you can do the distributive property, because remember, power is outside parentheses. You multiply. All right, now the bases are the same. You can just put the exponents equal to each other. So looks like x is -6. All right, well, we've got 2 more. All right. Well, if we're going to solve this, we're going to have to get the bases equal to each other. So I know that 125 is 5 to the 3rd power. Okay, well, this is really 5 to the -1 power. Okay, so then that means -x equals 3. So x is -3. Now sometimes you have a problem a little bit more involved. So you might have e to the x squared equals e to the 4x times 1 over e to the 4th. Okay, so all the bases are e, so we just got to simplify this one and write it as a negative exponent. All right, now we got common bases, and we're multiplying common bases, so that means we can add the exponents. And now we got an equation with one term equal to another term that have the same base, so now we can just put the exponents equal to each other. Alright, so using the zero product property. Alright, and then this would be factors of 4 that add to be -4, so -2 and -2. Alright, so x equals 2. Okay, sorry about that, y'all.